If you've watched many of my videos, then you'll know that my go-to scope is a Tektronix. In particular, it's this one. So it's a Tektronix 3052. Quite an old scope now. Very nice, very capable, and it's easy to use. It doesn't have all the bells and whistles of more modern scopes, but it does the job, and as I say, it's quite an easy, nice scope to use, and I've got used to its quirks and foibles that I'm sure you know that all scopes have. But you will have noticed in the videos that the display was quite dark and difficult to read. And I hadn't really noticed it to any huge degree. I was aware that it was getting darker and hard to see on the camera. But I have another 4-channel version of this scope that I sometimes use, and I needed to use it a few days ago. When I switched it on, I then realised just how bad the 2-channel scope had got, and the 4-channel was probably 3 or 4 times brighter. So I decided it was time to change the CCFL backlight tubes on it. I've done this to quite a few of my bits of equipment, and it's not difficult, but it does vary from machine to machine. And if you've ever done this, it's just really a case of getting the backlight out. So firstly removing the display and then dismantling the display to get the tubes out. Now some of these displays are a bit cryptic in the way they're assembled, so it's a case of trying to figure out how to get it apart in a non-destructive way. So this is not really about the process of changing the backlight. There's plenty of videos online of people doing that. Incidentally, I apologise for the flicker on this power supply. It's not apparent in real life, it's just an artifact of the camera shutter speed. This video is about the difference it makes. Again, they vary in kind of diameter of the tube, length of tube, and you need to make sure that you get the right size for the piece of equipment that you're going to use. But also you need to make sure that you avoid very cheap Chinese almost disposable tubes. They're extremely poor, and you probably find the output is a lot darker than the one that you're replacing. What I've done here is obviously I've dismantled the scope. I've dismantled the display. Unfortunately, with this display you do have to separate the actual LCD from the backlight, which is a bit of a pain. But what I've done so far, this particular display has 2 tubes, one at the top, one at the bottom. The bottom tube I've already replaced. I've put a new one in, so I got some replacement tubes. I've replaced the one that's hooked up to the supply, and what I'll do now is power it up. I've got the supply set to the same current limit as the CCFL inverter in this particular scope. It runs at about 2.3 milliamps. And when I switch it on, you'll see how bright this tube is. And then what I'll do is I'll swap this over with the old tube and we'll compare them. I'll try and do a side-by-side comparison on the video, but I don't know how well that will come out, because obviously the camera is going to try and compensate for the difference. I have locked it, but it still seems to want to compensate to a certain degree. The long string of resistors is to allow the power supply to supply the required current to the tube without the current supply tripping. And the problem is that the tube needs about 1100, 1200 volts to strike, and then it runs at about 350, and that's way outside the acceptable range for the power supply. It will just trip on current when the tube tries to strike. So the resistors even that out, and it allows the power supply to function correctly. The reason I've used a whole string of them is that the individual resistors have a peak voltage tolerance of about 150 volts, and if I tried to use a single resistor, it'd just arc over and probably burn up. Not because of the current and the power it's dissipating, it's just that the voltage across it would be too high. Okay, so I'll turn the lab lights off and then we'll do a power up of the new tube. Now incidentally, if you are replacing these tubes, they do have an initial phase they go through where they will get brighter. They do that anyway each time you power them up as they warm up, but the first time you power them up from new, they will start off fairly dark, and get progressively brighter over the first hour or so of use, and then they will always be initially brighter and getting brighter as they warm up. Now I've just plotted a graph for the particular tube we're looking at here. So the bottom scale is in minutes. I took a reading of the brightness every minute. The left hand scale is fairly arbitrary, it's just the value that was coming out of my light meter. But as you can see, the initial few minutes it brightened up. Now this is probably due to the warming of the tube, and then it progressively warmed up, and now when I power it up it comes up to about this point, and then as it warms up it gets brighter again. But this initial burning phase did increase the brightness, the light output, by about 26-27%, so it does make quite a noticeable difference. Okay, before I power this up, I'm just going to move this out of the way. I don't want to destroy it. We are looking at some fairly high voltages. I'll turn the lights out, and now I'll power up the tube. So we'll give it a few minutes to warm up, and then we'll have a look at it. I'll then put the old tube in and do the same and see if we can do a direct comparison. Looking at it with the naked eye, it is quite painful to look at. It is very bright, probably much brighter than it appears on the camera, and it's not something you'd want to keep staring at for a long time, and it is getting very rapidly brighter, especially the left hand end. It's very intense white, and here it's running at, as I say, 2.3 milliamps, which is the current that goes through it when it's in the scope. Ignore the voltage, it's saying just under 900 volts here, but that's at the input to the resistor string, so the tube's actually about 350 volts once it's struck. Okay, so it's had about a minute to warm up. It is now fairly painful to stare directly at, so what I'll do, I'll power this off and we'll try the old tube and see how that looks in direct comparison to this one. Okay, so I've now got the old tube hooked up. We'll power it up. Now, straight away to the naked eye, what I can see is this has got a distinct kind of pinkish tinge to it. It is starting to whiten up as it warms up, but it is nowhere near as bright at this point. We'll give it a minute to warm up and see how it develops. Okay, so it's had about a minute. That's the same as the other one had to warm up, and it's very apparent that this one is nowhere near as bright. It's running at the same current, 2.3 milliamps, which is what it runs at in the scope, but it's very apparent it's nowhere near as bright, and while it's giving out quite a lot of light, it's much duller. It's quite easy to look at, especially from here down to this end. This bit's a lot brighter, but again nowhere near as intense as the new one. It's not now getting any brighter. It's just kind of sitting there at a fairly constant intensity, and of course this one's already well burnt in. It's not going to improve over time now, it's just going to get darker, but it is nowhere near as bright. Okay, so what I'll do now is I'll replace this tube with a new one, get the scope reassembled, and then we'll have a look at it and see if the display is improved at all. Okay, if you're interested, this is the tube that came out. This is the one I've replaced so far. It's definitely showing signs of aging. It's definitely dark at the ends, and it is much darker all the way along. It's kind of a light brown colour compared to the white of the new one. So as I say, I'll get the second tube replaced, get the display and the scope reassembled, and then see how it looks. Okay, so the scope's fully assembled. The display is much brighter. It's probably at least twice as bright as it was. Hopefully you can see this on camera, but much more pleasant to look at. Even with the backlight turned right down, it's still brighter than it was with the old tubes in. So hopefully that'll keep it going for another 20 years.